Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Honors Algebra 2 class. Today, guys, we're going to talk about distance formula, midpoint formula, and circles. Today, gentlemen, and for the rest of this chapter, we will be studying what's called conic sections. And there are 4 conic sections, okay, which include circles, of course. We're going to learn that today. Parabolas, ellipses, and hyperbolas. Those are the 4 conic sections that we're going to learn, and those are the only 4 conic sections that there are. These are known as conic sections, gentlemen, because they originate from or are formed by different cross sections of right circular cones. Okay? I gave you 4 circular cones here, and I'm going to show you how you get the conics from these. You don't have to do this, guys, but I like to show you what it is you're doing. Where is it that it's coming from? What's behind all of this madness? If I take a sheet of paper, that's what these yellow things are here. If I take a sheet of paper, let's say, or let's say a razor blade, and I cut immediately right down the middle horizontally through the conic section, I get a circle. If I take that blade or piece of paper and I cut it vertically, I get what's called an ellipse. If I take that slice and I cut it at an angle, I get a parabola. And if I get that same piece of paper and I elongate it though, and I cut vertically through both cones, I get a double parabola, which is called a hyperbola. Okay? And those are the 4 conic sections. Today we're going to focus on circles. So let's learn about circles, boys. Oh, that doesn't look nice. Let's try that again. All right. The circle, midpoint, and distance formulas, guys. A circle is any set of points that are equidistant from the center point of the circle. Equidistant means it's the same distance. So when you have a figure, which in this case is a circle, that is made up of a set of points that are equidistant from the circle, it's called, from the center, it's called a circle. The radius is that segment that is equidistant from the center of the circle to any point on the circle itself. This is the radius right here. And the radius, okay, is constant throughout the whole circle. All radii of the same circle have equal lengths. So if I take that idea, a circle is formed like this. This distance, then to here, here. All of these are equal, guys, because these are all radii. And all of the points on the outside of the circle, they're all equidistant to the center. They're all the same distance. That's what creates a circle. These points here are all equidistant to the center. Kind of like spokes on a bike. And that's what creates a circle. All radii are equal. And that's what defines a circle. Are you with me so far? Now, a diameter, gentlemen. The diameter of a circle, okay, is any segment that goes from one point on the circle to another point on the circle through the center of the circle. So the diameter goes from one point on the circle through the center of the circle all the way to another point on the circle. So if you really look at this figure, the radius is half of the diameter, and the diameter is 2 times the radius. So if the radius is 5, the diameter is 10, and vice versa. If the diameter is 10, the radius is 5. Does that make sense, guys? I know it's basic, but I really want you to understand it. I don't want you just to look at it like you have in the past. It's not your fault. Oh, okay, the radius is that little line that goes from the center to the line. No, no, no. Let's understand it. The radius, yes, it is a segment that goes from the center to the outside point, okay? But that is what makes the circle. That is what defines the circle. You with me here, boys? Okay. Yes? Okay. Let us continue then, gentlemen. Sometimes you have to find the midpoint and or distance of the segments in order to find the radius or diameter of a circle using the following formulas. The midpoint formula, which is capital M, is literally the average of the x values and the average of the y values written as an ordered pair. It's an xy point, okay? The midpoint of the diameter is the center. Let's think about that statement that I just made. If I give you a circle and I want to find the center of that circle, well, guess what? The center is the midpoint of the diameter. So the midpoint of the diameter equals the center. So it's very important to know midpoint because that's how you find your center. Now, to find the length of the radius or the length of the diameter, you use the distance formula. No, it's not the distance equals rate times time formula. That's uniform motion. This is a distance between 2 points or the length of a given segment. So the distance from any point on the circle to the center of the radius, okay, is the radius. So the distance from any point on the circle to the center is the radius. If I want to find the diameter length, how would I find the radius? Divided by 2, right? Because isn't the radius the diameter divided by 2? If I have the radius length, how do I find the diameter? Multiply by 2. But to find that length, to find that distance, d equals x2 minus x1 squared plus y2 minus y1 squared. Now, let's get to work. I have a picture here of a circle with an h and a k, an r, and an x and a y. These are the points that you need in order to form the function of a circle. And I don't know why it's so blurry. Sorry, guys. And the standard form of an equation of a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. If any of you have been paying attention, hopefully you'll say, wait a second. I know this h and k. We've talked about this. What does the h do to a function? Makes it left or right, correct. If you have x minus a value, it's going to be to the right. If you have x plus a value, it's going to be to the left. What does the k tell you? Up or down. In this case, it's also opposite. A y plus a value is going to be down. A y minus a value is going to be up. And then, of course, I have my radius squared. Okay? My hk is my center. Remember, that's the midpoint of the diameter. My radius is half the distance of the diameter. And this xy is simply an ordered pair on the circle. Sir, my brother. Yes, for circles, the h and the k both are opposite. Thank you, my brother. Good observation. So, how does this work, Moto? That's great. That's real nice. How does it work? First of all, let's talk about graphing a circle. First thing you want to do, my brothers, is find and graph the center of the circle, which is your hk. Then find the radius and literally move that many units up, down, left, and right from the center point of the circle. Remember what the definition of a circle is. It's a set of points that are all equidistant from the center. So hopefully this will make it come to life for you. For this function right here, what's my h and what's my k? What's my center, which is h and k? Don't be afraid. There's nothing there, so it's 0, 0. Is there an h here, guys? Is there a k? 0, 0. What's my radius, gentlemen? Well, remember that 16 is r squared, right? So my radius is 4. So now, let's follow directions. Find and graph your center. 0, 0. Sorry. 0, 0. Now, my radius is 4, correct? So I'm literally going to go up, down, left, and right 4 units. So up 1, 2, 3, 4 units. Down 1, 2, 3, 4 units. Left 1, 2, 3, 4 units. Right 1, 2, 3, 4 units. Connect the dots, guys. You have a circle. Why, Moro? Remember the definition. A circle is defined by a set of points that is equidistant from the center. Isn't this point over here 4 from the center? Isn't this point over here 4 from the center? Isn't this point over here 4 from the center? And isn't this point over here 4 from the center? Does that make sense now? Promise, guys? See how powerful that radius is? That's what creates the circle. Sir, my brother. You're always going to have 5 points. Thank you, my brother. Yes, because you're going to have the center and then the 4 points, which are the extension from the center to the circle using the length of the radius. Yes, sir. Thank you, my brother. We good so far? All right, let's crank it out. What's my center here, gentlemen? I love it. Good job, guys. Negative 2, 3. What's my radius, my brothers? Bam. So, graph my center. Negative 2, 1, 2, 3. Now I'm going to go 5 up, 1, 2, 3, 4, 5. 5 down, 1, 2, 3, 4, 5. 5 left, 1, 2, 3, 4, 5. 5 right, 1, 2, 3, 4, 5. Connect the dots to the best of your ability. And bada bing, bada boom. Not bad, right? Okay. Let's move on. What's my center here, brothers? Well done, kid. Well done. 5, 3. What's my radius? Excellent, guys. So I'm going to go 1, 2, 3, 4, 5. Up 1, 2, 3. That's my center. And then from my center, I'm going to go 3 up, 3 down, 3 left, 3 right. And that's my radius. So 3 up, 3 down, 3 left, 3 right. And that is how you graph a circle. Not as bad as you anticipated, is it? Yeah. Now, like everything in math, guys, it's not always given to you in a pretty form, okay? Sometimes, my brothers, we have to write an equation, but before we write that equation, we have to put it into vertex form. Uh-oh. But let's walk before we run. When given the center, guys, HK and the radius, that's the easiest thing in the world to do, to write a function. Simply plug in the h, the k, and the r values into the standard form of the equation. Y minus h squared plus x minus h squared plus y minus k squared equals r squared. For example, what is the equation of the circle with center negative 5, 4 and radius 3? Well, plug it in. X minus a negative 5 is plus 5 squared plus y minus k, 4 squared equals 9. Done. To give you the center and the radius, it's literally plug and chug. Just plug it in and knock it out. Okay? And we know how to graph that already. Number 2, same thing. What is the equation of the circle with a center of 4, negative 3, and a radius of 6? X minus 4 squared plus y plus 3 squared equals 36. Beautiful, guys. Fantastic. Does that make sense? Now, they're not always going to give it to you nice and easy like that. Sometimes, my brothers, they're going to give you a polynomial. And when given a polynomial representation of the circle equation, you must complete the square for both the x values and the y values. I am not going to reteach completing the square super detailed, guys. I'm going to go relatively quickly because we've learned this already. If you do not know it, you do not remember it, you need a refresher, please go see my videos. And thank you, brothers. So we're going to complete the square as if we were solving, okay? What do we do always? We separate the x's, the x squared and the x, and in this case we're going to separate the y squared and the y, and any constants we're going to put on the right side, which in this case the 8 is there already. So I have x squared plus 8x, give yourself a space, y squared minus 10y, give yourself a space, equals 8. Are you with me so far? Now to complete this square, guys, please remember I'm going to do it in purple so you know it's different. I'm going to add the b over 2 squared to both sides, but I have 2b over 2 squareds this time. Okay, and wait, and this should be plus. Okay, so my b over 2 squared for my x is 4 squared, which I'm going to add to both sides. My b squared over 2 for the y is negative 5 squared, which I'm going to add to both sides. I'm going to stop there for a second. Does that ring a bell? Does that make sense? You remember that? Okay, so let's do it. Complete the square here. What is this? X plus 4 squared. Beautiful, guys. Plus y minus 5 squared plus equals. You got 8 plus 16 plus 25, 49. Bam. Bam. Now, guys, this is where the beauty comes. What's the center, y'all? Sorry about that. What's the center? Yeah, negative 4, 5. What's my radius? 7. So, let's graph it, just for giggles. Negative 4, 5 is negative 1, 2, 3, 4, 1, 2, 3, 4, 5. Now I'm going to have to go above my graph here because I only have a graph up to 10, but you'll see the point. So now my radius is 7, so I go 1, 2, 3, 4, 5, 6, 7 to the right. 1, 2, 3, 4, 5, 6, 7. That's an estimate up. 1, 2, 3, 4, 5, 6, 7. That's an estimate. One to the left of that. And then 1, 2, 3, 4, 5, 6, 7. And bada bing, bada boom. There's my circle. Not bad, right? Okay. Remember I had told you guys when we were completing the square with quadratics, I said, guys, this is going to come back, so please know it. Well, here it is. All right, this one I'm going to go pretty fast, okay? I'm not going to graph it. I just want to write the equation in standard form. I'm going to collect my x's together. I'm going to collect my y's together. I'm going to make sure my constants are on the right side. Now I'm going to add my b over 2 squared for my x to both sides. And then I'm going to add my b over 2 squared from the y to both sides. So this is x minus 3 squared plus y plus 7 squared equals 8 plus 9 plus 49, and that's 66. What's my center? 3, negative 7. What's my radius? Leave it in square root form. Okay, guys, sorry about that. So we were asking for the radius here in this case. And a lot of people get a little bit confused here, so let's talk about this right quick. We know that 66 is r squared, right? So guys, don't make a mountain out of a molehill. Find the square root. R equals square root of 66. Moro, don't we need an actual value? Well, if I did ask you for a value, you could put that into a calculator. If the SAT asked you for a value, you could put that into a calculator. But roughly, that's about 8.1, 8.2, right? Because square root of 64 is 8, so it's got to be a little bit bigger than 8. And that's it. Does that make sense, guys? Not bad, right? All right, let's continue. Yes, sir. Okay, that's a great question. Moro, shouldn't it be plus or minus? Sorry about that. My board is having a little bit of a snafu today. Shouldn't it be plus or minus? Yes, it is, but it can't be minus because you cannot have a negative distance. Thank you very much, sir. Thank you. Okay, so let's talk. When given the center and one point on the circle, or the end points of the diameter, you must use the midpoint and or distance formula in order to find the radius. Once found, plug in the values into the standard form formula. This is where people get hurt. It's not the vertex form. No, it's right here. So let's use logic. Find the standard form of the equation of a circle if the center is at 0, 3. So that means that my HK is already 0, 3, right? That's my H and K. And it contains the 0.37. Guys, I could tell you what to do and plug this formula, plug that formula, but that doesn't really show you what's happening. So let's do a little mini visual, okay? Let's do a little mini visual. 0, 3 is my center. And this circle goes through 3, 7. Goes through here. So this is my radius, and it goes something like this, right? So guys, what do I need to find? I need to find the radius, right? How do I find the distance between 2 points that are on a slant like this? The distance formula. Good job, guys. So distance equals, remember, x2 minus x1 squared plus y2 minus y1 squared. So label and plug it in. Okay, so now we're going to find the distance, guys. And in this particular case, guys, please label. Make your life easy. We're finding the distance of the radius in this case. Okay, because I'm going from the center to the point on the graph. So that's the radius. Label x1, y1, x2, y2. So x2 minus x1 squared plus y2 minus y1 squared is going to be 9 plus 16, which equals square root of 25, which equals 5, and that is my radius. So now, what's my function? My function is x minus 0 squared plus y minus 3 squared equals 25, which is r squared. Cleaned up, x squared plus y minus 3 squared equals 25. Talk to me, boys. Please, I'm here for you. Does it make sense? Okay. What happens now if I tell you to find the standard form of the equation of the circle with the endpoints of a diameter being at -5, -3, and 7, 2? Let's visualize. We got 7, 2, and then we got -5, 3. This is the diameter of our circle. Okay? That's all we have. I need a center, which is the midpoint of the diameter, and then I need the radius length. So first, let's find the midpoint. The midpoint of the diameter. There you go, brother. X1 plus x2. So we've got 7 minus 5 over 2, comma. That's it. The y, the average of the y's. So this is going to equal 1, comma, -1/2. That is my center. And that's my HK. That's my midpoint. That's my center. So now we have it 1, -1/2. That's my center. Is everyone with me so far? All I found was my HK because it's the midpoint of the diameter. Now, step 2, guys. You have two choices. You can find the distance of the diameter and divide it by 2, or you can find the distance of the radius straight up. People don't like using the distance formula when there's fractions, but I will leave it up to you. What would you like to do? Find the distance of the diameter and divide by 2, or just find from the center to the point on the circle, in other words, finding the radius? You want to just do the radius one? Okay. So let's do this. This is your x1, y1, and this point here, which is 7, 2, is x2, y2. So my distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This will equal 6 squared, which is 36, plus, okay, remember this is 2 1/2, which is 5 halves, so that squared is 25 halves. I think it would have been easier to go diameter, guys, and divide it by 2, but that's okay. Is everyone with me so far? Now this goes to 2, right? Right? Common denominator? That goes to 72, right? You guys with me here? Okay. So then this will equal 97 over 2. That's nasty. I really don't like that. Because now I have to rationalize square root of 2 over square root of 2. Ouch. This is really ugly. So what's that? That's 194? Yeah. 194, square root of 194 over 2. But then I could break up 194. 194 divided by 2 equals 97. So no, yeah, I don't want it like that. You know what, guys? This is ugly. Oh, wait, I did mess up. This is 5 over 4. Okay, that's 5 over 4. Wow, this is even going to make it uglier or nastier, though, guys. Let's not, how about we abort? Let's abort. Let's not do it with fractions, because as you can see, it gets real nasty. Let's just do the diameter. Let's just do the diameter and then divide it by 2. It's going to be easier working with whole numbers. So distance of the diameter equals, we got x2 minus x1 squared plus y2 minus y1 squared. So that's the square root of 12 squared is 144 plus 5 squared is 25. So that equals the square root of 169, which equals 13. Now that's my diameter. So what would my radius be? Half of that. Very good. So my radius would equal 13 over 2, which equals 6.5. But you don't want to work with decimals. You want to stay with fractions. Okay? Now I have my center. Now I have my radius. So my function is x minus h squared plus y minus k squared equals my radius squared, which is 169 over 4. It's better that way. You don't want to work with fractions in the distance formula. Talk to me, boys. I'll pause for a second. All right, guys, let's see if this really has digested. Find the standard form of the equation of the circle with endpoints of a diameter 2, 8 and negative 6, 4. Well, first step, let's label. x1, y1, x2, y2. You don't have to draw this sketch out, guys. I'm doing this because I want to be a good teacher and I want to show you what's happening. This is negative 6 and 4. No, 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 no. Pay attention, Moto. Pay attention. So it's here. So this is my circle. I want to find the equation for it. Again, why do I do that? Because I know that they gave me the diameter. I visually see what they gave me. Now, let's solve. How do I find my center? The center of the diameter is the midpoint, right? Okay. There you go, buddy. So my midpoint is going to equal negative 6 plus 2 over 2, comma, 4 plus 8 over 2, which equals negative 2, comma, 6. That's my center. Moto, why is it your center? Because the midpoint of the diameter is the center of the circle. Does everyone see that? Please. Step 2. This is my center. Now, again, you have two choices. You can find the distance of the diameter and divide by 2 because radius equals diameter by 2. Or you could just simply say, nah, these are pretty numbers. Let's just go from the center to a point on the circle because that's my radius right there. What do you want to do? In this case, it really doesn't matter because they're all whole numbers. Yeah, I would choose in this case, just straight up, let's find the radius. So I don't want to confuse myself. So the distance of the radius is going to equal square root of, remember at this point here is 2, 8. x1, y1, x2, y2. So I've got x2 minus x1 squared plus y2 minus y1 squared, which equals the square root of 4 squared is 16 plus 2 squared is 4, which equals the square root of 20. That's my radius. Now, what's my function, guys? X minus negative 2, so x plus 2 squared, that's x minus h, plus y minus k squared equals my radius squared. So what does that equal? 20. Bam. Thank you so very much, guys. I hope you learned a lot. Have a great day. God bless you. And thanks again. Bye-bye.